Hi friends, in previous video I explained about the mixed combinatorial synthesis. In mixed combinatorial synthesis, a mixture of 27 products are synthesized in 3 different reaction vessels. In that, assuming a mixture of product is biologically active. From this biologically active mixture, the most biologically active compound is separated by a method of deconvolution methods. What is the meaning of deconvolution method? Isolation and identification of most active compounds from the mixture of compounds is called a deconvolution. For this deconvolution techniques are: first one, micro manipulation. In micro manipulation, each bead is attached to a particular product, and these specific products are separated from the bead and tested for the activity. And this micro manipulation method is based on the colorimetric analysis. We are testing the biological active compound by the color reaction. By seeing under the microscope, we can find the biological active compound. The second deconvolution method is a recursive deconvolution. In recursive deconvolution method, we are taking a mixture of 3 in this, we are taking a dipeptides, glycine, alanine, glycine, valine, glycine. In second vessel, we are taking glycine, alanine, this valine, alanine. In third reaction vessel, we are taking glycine, valine, alanine, valine, this valine. And each of these reaction vessel is treated with valine amino acid, producing of tripeptides, glycine, valine, alanine, glycine, valine, glycine, valine. In this, the 3 peptides will be glycine, alanine, valine, alanine, alanine, valine. Valine, alanine, valine. The third mixture, the tripeptides will be glycine, valine, valine, alanine, valine, 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 valine. And in this recursive decontamination method, each mixture is tested for the biological activity. Of these three, the third mixture is showing active. If it is showing activity, and this active compound is tested by synthesizing the individual tripeptides. These three tripeptides are individually synthesized and they tested. With this, we get the active compound from this. Next method is sequential release. Next decontamination method is sequential release. In this sequential release method, we are identifying the biological active compound. For example, we are taking a mixture of compounds. This is it. A, B, C, D, E, F, G, H, I, J, K, L, M, N. With this mixture we are taking. In the previous method, one mixture is showing the active. From that active mixture, we are separating the active compound by sequential release method. Here, for example, consider this K is an active compound, and this active compound is separated from the mixture by sequential release method. And this is first cleaved and tested from the beads. Cleaved from the beads and then tested for the activity. It's showing the biological active. Because of presence of one active compound, this mixture showing activity. That is what A releases. Cleaving from the beads. A, B, C, D, E, F, G, H, I, J, K. That is the active one. Due to the presence of this active compound, this total mixture is showing biological active. From this biological active mixture, we are separating the most active compound by this method. It's K, L, M, N. How means? That is what? This is split into small portions or small mixtures. A, C, F. In another mixture, B, D, E, H. In another mixture, we take another compound F G G I K L. In another mixture, M is L. Here, by splitting into small mixtures, tested for the biological activity, this is showing inactive, because in this no active compound is there. We conclude that no active compound is, this is inactive. By testing of this one, also showing inactive. It is showing activity. It is inactive. From this, after converting into small mixture, this third one showing this active. From this active mixture, again we are separating. Taking that active mixture, I K L, and this further split into small mixture, into small mixtures. G I, next K L, and further these are tested for the activity. It is showing inactive. If it is showing activity, it's an active compound. And by taking of this active compound, this again split into small portions. One is K L. This, it is active and inactive compound. In this way, we are identifying the active compound from the active mixture by sequential release method. Next, let us discuss about the tagging. In this method, the resin bead must have a multiple linkers. The resin bead must have multiple linkers. For example, we are taking this resin bead. This must have multiple linkers. In this process, the two compounds must be added to the resin bead. Out of these two compounds, the first one is the new structure to be tested, and the second one is molecular tag. It is due to presence of this multiple linker, two compounds are linked to the resin bead. One of these is the new structure to be tested, and the second one, the second compound will be the molecular tag. This molecular tag is a peptide, and this molecular tag is used for the coding for the each step of synthesis. And here in a molecular tag, these two multiple linkers This is one is the for the tryptophan acid, and tryptophan amino acid end, and this end is lysine amino acid end. Here in this process, first step 1, we are taking an acid derivative. Step 1, this acid derivative added to this linker, and producing NH by loss of water molecule, CO, CH, this is R, and here NH2. Now this tag 1 is added. The tag 1 is what? Amino acid 1. Amino acid, the first amino acid is added to the tag 1. Here this is become NH to this amino acid. First tag 1, amino acid 1 is attached to this one, amino acid 1 of NH2. Next, the step 2 is amine group is added. NH and CO, CH, please loss of HBr, NH, R dash. The next is NH, amino acid 1 of NH2. Next, tag 2 is the amino acid 2. Here NH, then CO, CH, NH, R dash. This NH amino acid 1. Now the second tag molecule, there is amino acid 2, NH2. Then next, step 3. Here R double dash acid chloride is added. Here NH amino acid 1, amino acid 2, NH2. Now here this is NH, CO, CH, NH, R dash. Next, by the loss of added to the CO, R double dash. Next, tag 3, this is amino acid 3 is added. This NH, amino acid 1, amino acid 2, amino acid 3 of NH2. For this NH, there is CO, CH, this is N, R dash, CO, R double dash. With this is a tag molecule, this is a peptide side chain, and this is a non-peptide side chain, and this non-peptide compound is cleaved from the resin bead and identify the structure of the compound. Let us discuss about the encoded sheets. This type of method is developed by a chemical company, Pfizer. resin beads are sandwiched between two sheets of inert polypropylene, and the sheets are fused together so that beads are immobile. Three sheets we are taking of a size, three sheets of a 6 into 6 centimeter size. Three sheets measuring a size of 6 into 6 centimeter size, and these three sheets are converting into 9 squares, and each square is coded with a 3-letter word like this. And we are taking the three sheets the one sheet of size 3 into 3 centimeters converting into 9 squares like this. One sheet is converting into 9 squares. Second one. These are sandwiching, fused together the second sheet. One. Three sheets. Top sheet, middle sheet, and the bottom sheet. And these are coded first. This is A, 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 B, A, C. Next. A, B, A, B, 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 C. AC, AC, B, AC, C. In the second one, the top sheet, the second sheet, BA, A, BA, B, BA, C. Next, BB, A, in, down of this one, behind this, BB, B, here, behind this, BBC. Next here, third, A, in behind this, BCB, BCC. Next, third sheet, CA, CAB, CAC. Here, CBA, in behind this, CBB, behind this, CBC. Here, CCA. In behind is CCB. Behind is CCC. And these three sheets are separating sheets. Separate sheets with this. Once we are separating, this is one sheet, second sheet, other sheet. This is a top sheet. What is top sheet? I am giving the labeling AAA, AAB, AAC. Next ABA, ABB, ABC. Next ACA, ACB, ACC. This is a top sheet. Next middle sheet BAA, BAB, BAC, BBA, BB, BBC. Next BCA, BCB, BCC. Middle sheet. Then bottom sheet is CAA, CAB, CAC. Next CBA, CBB, CBC. Here CCA, CCB, CCC. And these are separating, and these are the resin beads, and this is a top sheet. And after separation, the top sheet is treated with first unprotected leucine, F-mark leucine, F-mark protected leucine amino acid, and we are doing the deprotection the same way. Deprotection of this F-mark by using of piperidine. Here, once addition of this one amino acid to the resin bead followed by the deprotection of this F-mark, giving to this one AAA, AAB, AAC, ABA, ABB, ABC. Next ACA, ACB, ACC. To this resin bead, this leucine amino acid is added. First we are adding the F mark, there is a F mark leucine, this is a unprotected leucine followed by deprotection, giving the first amino acid is added to the resin bead. This is the top sheet. Then this one treated with F mark serine amino acid, then followed by deprotection. Here the resin bead, the serine amino acid is added to this resin bead. This is serine amino acid is added. The second sheet is BAA, BAB, BAC. Next BBA, A, B, 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 C. Next B, C, A, B, C, B, B, C, C. The next third, the bottom sheet is written with F mark, glycine, and second one, D protection. D protection. And this, so the bottom sheet, this glycine amino acid is added. Glycine, that is CAA, CAB, CAC, next CBA, CBB, CBC, next CCA, CCB, CCC. With this, the first amino acid added to the residue, and in this, all the beads in the top sheet is now attached with the leucine amino acid, and all the resin beads in the middle sheet is attached to the serine amino acid, and the bottom sheet, in bottom sheet all the resin beads are attached with glycine amino acid first. The next step is step 2. In step 2, and these 3 sheets again further fused, and here this is glycine, the middle sheet attached to the serine, and the top sheet is attached to the glycine. First sheet attached to the leucine, serine, and glycine. And again, in this in the second step, we are cutting these sheets in a vertical. That is, in vertical form, we are cutting these sheets into 3 sets. The first one, this is, and top sheet first row is the first column. In first top sheet first column we are cutting this A B A C, and this, in this way we are cutting here the first columns of each sheet. First columns of each sheet we are cutting here. This is the top sheet, first column, then middle sheet, first column, middle sheet. The middle sheet is what? B A B B A C. The next, bottom sheet, first column, bottom sheet, first column, C A B C A C, and this is attached to the first, attached to the leucine, and the middle attached to the serine, and the bottom sheet attached to the glycine. In the same way, the second one, three portion. The second column of top sheet. The second column of top sheet. Second column of top sheet, A, B, A. Next, A, B, B, A, B, C. Next, second column of middle sheet. Middle sheet, second column, that is it. B, B, A, B, 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 C. Next, second column of bottom sheet. The second column of bottom sheet, there is C, B, A, C, B, B, C, B, C. And here first attach it to this leucine. This is attached to the same serine. This is attached to the glycine. Next, third column of top sheet. Third column of top sheet. This ACA, ACB, ACC. Next, third column of bottom middle sheet. This BCA, BCB, BCC. Next, third column of bottom sheet is CCA, CCB, CCC. And here attached to the leucine amino acid, this middle sheet attached to this serine amino acid, and this bottom sheet attached to the glycine amino acid. Now, this second amino acid is added to the here with this F mark, leucine, followed by glycine. We are adding glycine followed by D protection. Here, by adding off to this, we are adding here. This is A, B, C. With this attached amino acid leucine. Next, we are adding the second amino acid as glycine. After reproduction, we are getting this dipeptide. Leucine glycine dipeptide is formed here. In the next, here we are getting serine glycine. The second one is BAA, BAB, BAC. The next, for this glycine attached to the second amino acid glycine, that is CAA, CAB, CAC, and this when treated with F mark, leucine, followed by D protection, here. The second amino acid, here. The top sheet attaching leucine. The second amino acid is attaching leucine. The top sheet is A, B, A, B, B, A, B, C. The middle sheet is B, B, A, B, 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 C, and this attached to the serine, and this now attached to leucine. With this, a dipeptide is formed. In the third sheet, there is a bottom sheet CBA, CBB, CBC. The already attached first amino acid is glycine. With this, now attaching second amino acid leucine. With this, a dipeptide is formed, and in this case, same way, the second amino acid is added, serine, followed by D protection. This F mark protected serine and D protection. The same way, the dipeptide is formed. Now I am writing for this only. Here the second amino acid is added, serine. Here also serine, dipeptide, serine. Here glycine, serine, dipeptide is forming in this way. After this, formation of dipeptides for the each separate sheets. Then and these now, and we are cutting this in the form of rows. In this way we are cutting this next. In the next step, this is glycine and glycine. No? For this one, directly I am writing here. By cutting up these sheets in this form, there is first one is this first top sheet is A is attached to the leucine glycine, and this is attached to the middle sheet of BAA. This is attached to the serine glycine, and this third top sheet, bottom sheet CAA. This is attached to the glycine. And the next one, the second one, this is in this way we are cutting. So, the first one, second one with this 3, third one with these 3. For the first one I am writing here, and this is when treated with another amino acid. The third amino acid first, serine, other one. Here it is attached to the A, B, C, A. This is what? Leucine, glycine, this name, F mark, serine, followed by D protection. The third amino acid is added, that is serine. For this, serine, glycine, serine tripeptide is formed here. In this case, this is glycine, serine tripeptide is formed. In the same way, we are taking for this second cut, this one in this way. These dipeptides react with another amino acid producing a tripeptide, and these last three are added to the next amino acid to produce a tripeptide. In the same way, this one is cutting in the form of this one to produce a tripeptide, and followed by cutting off these three, and followed by cutting off these three, we get the another tripeptides. In this case also, cutting these three and adding the third amino acid with this producing a tripeptide. By cutting off these three, followed by addition of next amino acid producing a tripeptide, and cutting off these three and addition of next amino acid producing a tripeptide. In this way, with this we are getting the tripeptides by encoded sheet method.